Today, we're diving into a topic that sounds like it's straight out of science fiction, but is actually shaping the future of technology. Quantum kinetics. It's a mind-bending field where quantum mechanics, the laws of heat, and statistics all collide. So, grab your thinking caps, because we're about to explore how the universe really works at its most fundamental level. First off, what does quantum kinetics even mean? Let's break it down. Kinetics is all about motion and change. How things move, react, and eventually settle into a state of balance or equilibrium. Think of how a hot cup of coffee gradually cools down to room temperature. That's kinetics in action. Now, add the word quantum. This tells us we're not talking about coffee cups anymore. We're talking about the bizarre and wonderful world of atoms and subatomic particles, where things can be in multiple places at once and can tunnel through solid barriers. So, quantum kinetics is the study of how these tiny quantum systems like electrons, photons, or atoms move, interact, and exchange energy over time, all while playing by the strange rules of quantum mechanics. It is what physicists use when the classical rules we learn in high school just don't cut it anymore. To really get a grip on this, we need to understand a few core ideas. One central tool is the quantum Boltzmann equation. It's like the ultimate traffic report for quantum particles, describing how their distribution changes as they zip around and collide with each other. Another key concept is the density matrix, which is a mathematical way to describe the statistical state of a quantum system. It helps us track how a whole collection of particles evolves over time, not just one. But perhaps the most fascinating idea is the dance between coherence and decoherence. Coherence is that special quantumness, the superposition and entanglement that make quantum mechanics so powerful. Decoherence is the process where the quantumness fades away, and the system starts to look and act like the classical world we're familiar with. Quantum kinetics is crucial for explaining exactly how and why this transition happens. It is the reason we don't see a cat that is both alive and dead in our everyday lives. So, where is all this theoretical stuff actually used? You'd be surprised. It's at the very heart of modern technology. In semiconductors and nanotechnology, quantum kinetics helps engineers model how electrons move through quantum dots and nanowires. It explains why your smartphone's transistors can be so incredibly small and efficient, thanks to a quantum effect called tunneling. In the world of quantum optics, it describes how lasers can cool atoms to temperatures colder than deep space, and is essential for developing secure quantum communication networks. Even in the quest for clean energy, plasma physicists use quantum kinetic equations to understand the behavior of particles inside fusion reactors, trying to replicate the energy source of stars right here on Earth. Speaking of stars, astrophysicists use it to model everything from the behavior of neutrinos and supernova explosions to the plasma that filled the early universe. And, of course, there's the big one, quantum computing. The biggest challenge in building a powerful quantum computer is fighting decoherence. Qubits, the building blocks of quantum computers, are incredibly fragile. Any stray interaction with their environment can destroy their delicate quantum state. Quantum kinetics is the tool scientists use to predict how quickly this decoherence happens, and to figure out how to protect the qubits and extend their coherence time. Without a deep understanding of quantum kinetics, building a functional quantum computer would be practically impossible. So, how does all the math behind this work? At its core is a beautiful mathematical object called the Wigner function. You can think of it as a special kind of map that bridges the gap between the classical world and the quantum realm. It allows physicists to represent a quantum state in a way that looks a bit like a classical system, using both position and momentum, which makes it an incredibly powerful tool for calculations. And the field is still growing. Scientists are pushing into exciting new frontiers. There's quantum thermodynamics, which is rewriting our understanding of heat and energy at the nanoscale. Some researchers are even exploring quantum biology, investigating if quantum kinetic effects play a role in super efficient processes like photosynthesis. We're witnessing the birth of entirely new disciplines that could lead to breakthroughs we can't even imagine yet. From the tiniest transistors to the mysteries of the cosmos, quantum kinetics is the silent engine driving our understanding forward. Thank you so much for joining me on this journey into the quantum world. I hope you found it as fascinating as I do. If you enjoyed this video and want to learn more about the amazing science shaping our world, be sure to hit the like button and subscribe to the channel. Thanks so much for watching. See you in the next video.